Welcome again, and welcome to this afternoon session on the future of mobility. My colleagues have introduced already a lot of the sessions, so that makes my job a lot easier. I'm Helmut Spudig. I'll be guiding you through this session with a lot of experts in this field. Now, mobility is definitely one of the key drivers of climate change, so it can also be one of the key enablers of mobility, of climate change solutions, if we do it right. What is the future of mobility? We face new ecological conditions, changing social structures, new customer profiles. We're changing forms of use, such as multimodality, new technological possibilities. All those represent an opportunity for the global mobility industry. In this session, partners of AC Styria, which is the cluster of 300 companies from the automotive sector, aerospace, and rail, will give you an outlook on what to expect in the next few years and what innovations from Styria you can count on. Our first presentation, which is in a hybrid mode, our presenter will be online and joining us in a moment, is all about big data. The digitalization of many areas of industry, businesses, and life make large amounts of data available. And by using artificial intelligence, we can make use of those and meet the challenges of our time. But as humans hand over cognitive work to machines, there is skepticism and there's growing concern. So new technologies enable European artificial intelligence to handle data in a secure and trustworthy manner. Now, to talk about this, I welcome Wolfgang Kienreich, who is Director of Business and Markets at the Know Center GmbH. He studied computer science in Graz and communication science in Vienna. He founded a startup specializing in visualization technology and worked for Hyperwave Research. Now, he joined the Know Center in 2003, where he managed the research area for knowledge discovery and visualization. He has authored a lot of scientific publications that focus on knowledge visualization and visual analytics. Since 2014, he's Director for Business and Markets at the Know Center. Please welcome Wolfgang Kienreich, and the floor is all yours.
Thank you for the introduction, and I'm happy to talk to you today about my favorite topic about artificial intelligence, about data-driven artificial intelligence, and how it is a universal tool for mobility of tomorrow. I will share with you my presentation now. Well, it seems that we have a problem with sharing my presentation. However, I can just tell you a few things, and it isn't as if there are that many pretty pictures in my presentation anyhow. So let me just start, and if we get this technical problem fixed, then we can continue, and you also see some summary of what I'm telling you. Now, first of all, who's talking? Actually, not an AI, but that would be entirely possible. So who knows? You see that my face is here blended into a background, and who knows if this face is even real or is computer generated. It would be absolutely possible today to fake all of this and have an AI talk to you, at least until we come to the discussion. Then it gets pretty tricky. But that's actually the topic of my talk. So these AIs are very powerful and a bit frightening, and the question is what we do about it. Who's talking? Well, I come from the Know Center, which is one of Austria's COMET competence centers, and our focus is on big data and AI research. On data-driven AI, we have about 150 data and computer scientists working at our center in Graz. We have a huge network of industry partners and research partners, obviously. And one thing which is of specific interest for today's session, I think, is that we have a so-called COMET module, which enables us to do fundamental research on data-driven artificial intelligence with a focus on trustable AI for the next 4 years with 10 PhDs. So that's quite some research power we have here, and also quite a lot of output we are doing. I'll try again to share my screen. Now I can share my presentation. Give me a moment to do this. Let me start with a rather simple question. What is on our collective mind? I mean, talking about future mobility, we talk about a topic which is in the future, influenced by what is on our minds now, and a topic which touches about every aspect of our daily life. Mobility is omnipresent. So what's on our collective mind? I think we can agree that the global pandemic is. A second thing is that, of course, climate change is. a nice case of, so to say, short-term, long-term memory. Keep in mind climate change, but currently probably we are all a bit preoccupied. And of course, what is driving from behind is the digital transformation. It's pushing most business areas, many areas of society, and these three trends raise certain expectations towards mobility. Of course, I can only pick some, but I chose some almost at random, or which I was personally in touch with. So one is the global pandemic, of course, makes an expectation or raises expectations towards resilient supply chains. So suddenly mobility in the case of logistics should ensure that supply chains are resilient and don't break down if you have shortages due to the pandemic. And the second thing is that mobility suddenly, with lots of home office going on, is no longer a daily commodity, but something you need much more on demand. Probably many of us are not traveling as much as we used to. So this is mobility on demand is also something which gets important in the global pandemic. On the climate change level, of course, everything is about electrification, and we have been talking about this for a long time. But also about structural change in the modalities of our mobility. And looking at digital transformation, which is of course more an enabler than an expectation raiser, but still, I think in the eyes of the public, we are expected to produce autonomous vehicles relatively soon, and we can discuss up and down if it's more a legal thing holding us back or a technological thing, but nevertheless, where are all these autonomous vehicles we want to have? And the same goes for mobility services. It's still not a trivial task to go to a strange city where you have not been before and get your electrical car for a day or two and find out where to charge it. So mobility services are also something which through the digital transformation comes with a lot of expectations. This goes together well if you take a look at what people see as mobility trends. I picked two trend barometers or two trend predictions here. And of course, there is electrification very much on top. Of course, autonomous vehicles are very much on top. Also, this aspect of somehow diversifying, integrating different travel modalities, and of course the merging or integration of digital domain and what you could call a mobile ecosystem. So I think the trends and the expectations are pretty much clear here. So from this, let me develop a few tasks, a few characteristic tasks which mobility is expected to solve these days and in the future. And there's a rough distribution of industry versus society here, but you cannot separate the two, and so take this only as a rough guide, this left and right sides here. So what will the future mobility be expected to do? What are the tasks? One task it has to fulfill is that it has for the industry to support dynamic production. Long gone are the days where we create one Ford T model in all colors as long as they are black. Today, you want many different variants in all the products you build, and supporting this dynamic production where you have changing supply lines based on different demands, but also, as we saw before, on resilience issues in the case of some catastrophes. You need to support that with the mobility modality, which is different from your usual milk run. Supply chain integration is a second thing. We are reaching, in the case of the well-organized big companies, the limits where we can do optimization with data-driven methods within the company. And what we have to do is to do this across the supply chain. But optimizing across the supply chain, again, requires an unprecedented dynamic of my mobility modalities, which are available to me. And of course, in the end, I also need mobility recommendation services for this. So I also have to try to not only decide myself and do all the planning myself, but have the planning on a multi-perspective level. This also brings me to the more general topic of multi-perspective travel optimization. This is another expectation that we do no longer organize our traffic based on observations made years before and then put into models, but on a near real-time basis and from multiple perspectives. Taking into account that in the future, perhaps we will see hydrogen-based transportation of goods in parallel with mostly electrified public transport and so on. It's clear, I think, that to reach certain goals, for instance, in Graz, the Feinstaub-thematic, the dust topic is very prominent. To reach different goals, we need to have a very good optimization here. Last mile delivery integration, another thing that was a reason for many jokes now in the pandemic is that you deliver the last mile. I think that the current running gag is that DHL said that they will now deliver only between midnight and 4 in the morning because then everybody is home. I hope that was just a joke, but still we have somehow to deliver the last mile integration. We have somehow to integrate the last mile delivery with all our other activities. And of course, all these mobility ecosystems need a lot of data sharing, which has to be established. So some tasks for future mobility. From this, we can easily develop some requirements. And I tried to point out some shared requirements in the face of digitalization. So the tools we will need is at once integration and alignment. So the amount of data sources and of various systems we have to integrate is much too big for us, and it's much too dynamic to do this or manually, so we have to automatically do this. We need decision support, and in many cases, not only decision support, but also automated decision making. In the case of the self-driving car, this is very clear, but in the case of the self-organizing supply chain, it is perhaps less clear that the amount of information is simply too overwhelming to really have the human enter into each decision loop. And also our optimizations must get more automated here. And for all of these things, there is a universal tool which emerged during the last 5 or 10 years as a really usable thing, which is data-driven artificial intelligence. Now, data-driven AI is set apart from current AI or from historic AI by the utilization of large amounts of data. So the idea is you take a lot of data sources, you integrate them, you analyze the data, and then you train something called a model. And this model can then predict what's going to happen. It can prescribe what you should do, and then basically do your magic, whatever you want. In reality, this is a long way, and centers like our No Center have a lot of work to do in AI research. So it's a long way breaking up data silos, for instance. It's a long way establishing standards for data exchange. It's also a long way, we realize, to be theory inspired, because just building your statistical model and hoping for the best doesn't work. You also have to consider what's already known in the discipline, theory inspired AI. And of course, you have to be able to generalize. Nice that you know it works in a small town, but does it also work in the next small town, or does it also work in a large town, and so on? One universal requirement for AI in all of these is about trust. So customers will only accept mobility solutions based on trustworthy tools. Oh, wait, this holds true for the digital domain too. So I think we are already long past the point where we only accept trustworthy tools. This is why we have to stick these nice things on our cars every so and so many months, telling us that the car is ready to drive and everything's okay with it. Of course, we have to have something like that, some controlling, some compliance mechanisms also for our digital solutions. Then we will have regulations in the EU which will require trustworthy AI. So an EU regulation is on its way. Most mobility applications will count as critical systems under this EU regulation, which will mean that they will have to be certified. So we have customer expectations, we have legal requirements, and of course, only trustworthy tools will realize the full commercial potential. Just imagine which company will join a platform economy where its data is open to others, or where its data cannot be tightly controlled. So there is a lot of reasons why we should have this trust as the focus. And how can we make sure that we trust can trust our AI? There are some central concepts which I only want to put here as teasers for you. So if you are interested in depth, then contact me please at the No Center, and we can talk about these things in more detail. Central concepts for current AI trustworthiness are multi-party computing, federated learning, and explainable AI in general. For multi-party computing, let's do some magic. Say that multiple parties supply data to a shared computational task. Say we want to compute the average age of the people in this session, but you do not want your personal age to be exposed. For some people, this is like me, this is still critical, or this is already critical. But the computational result, so the average, should also only be available to a single party. Suffice it to say that this is possible with some mathematical tricks. And it is possible in such a simple picture like here, but it's also possible in a supply chain scenario, in a really complex scenario. And this is research which is actually now going on and now bearing the first fruits, and which will enter the markets in the next years. This is, by the way, only widely related with or remotely related to all the blockchain topics and so on. Federated learning is a development from this, where multiple parties can do this AI model training together. So you can join in, say, creating a global digital twin of a whole supply chain, but your data stays your own data. So many suppliers can contribute to supply time prediction, for instance, while no supplier shares stuff they don't want to share. And explainable AI in general, if you take a look at the very left picture, there is some problem with the machine. A standard AI would, or a heuristic system would have a logic tree or decision tree and would tell you then, well, the problem is because of this and that. But this is not flexible, and we have been building neural networks to be more flexible and to do such things better. Unfortunately, once they have learned a thing, you can often not open the lid and look inside what they have actually learned. And we are now developing methods where you can verify why a model works like it does. And this is, of course, important once there are legal restrictions in place and requirements in place to verify if an AI works in a certain way. So coming to my conclusions and to questions and answers, if there's place for that, and I will comment on the one question I saw. Future mobility topics revolve around digitalization, and data-driven AI provides the essential toolbox for digitalization these days. But only a trustworthy AI will be allowed, accepted, and adopted, especially in the mobility context, where most of the applications are security critical. And just to give you 3 examples, we will have delivery vehicles autonomously driving the last mile to your doorstep only if we can verify that, and not only experimentally, but really by taking the AI apart and putting it back together, that it fulfills certain criteria. Electric car production suppliers will share a digital twin of the final product and optimize their companies together, but only if they can be sure that their data will only be shared to the extent they intended, and will not fall into the hands of third parties. And traffic optimization, including on-demand mobility services ordered via smartphone, will work only if we can ensure that the people using these systems trust the systems. Otherwise, they won't be used at all. So this concludes my presentation, and I would now like to answer to one question, which was about the mobility trends, how the shipping and maritime industry can learn from the experiences in automotive and aerospace. I think learning from the experiences means identifying points where similar solutions have already been done, and we can, of course, do this. And we already have transferred a lot of experiences from automotive to for instance, to pharma and life sciences, which is a pretty big jump, I suppose, compared to shipping. A very concrete issue in the model generation is that you can do something called a model transfer, or also learn with data from one domain and then use the model in another domain with some adaptation. So there are even ways in AI to use something you learned in automotive and apply it to shipping.
Thank you, Wolfgang. That's been a really good introduction to this session. You already picked the one question. I didn't know that you can see it, so you actually were taking on my job, but that's all right. I have a question that I would like to follow up. One of the issues in all this is social change, and we've touched upon this. And my question is probably something you can only answer on a personal level, but do you think that this past year of pandemic experience, or actually 14 months now, 15 months, has made us less car crazy because we've learned to stay at home. This conference has almost no attendance physically, but lots of attendance online. So do you think that we have less of a car craze than we had before? Or do you think that it's actually been a pushback because public transport has been considered unsafe by many people? And so they've been taking their cars where before they might have taken the subway or the regional train. What's your feeling on this?
Probably I can't talk too much about car craze, driving a small electric car, but I think many of us in Graz know the phenomenon of the 6 o'clock in the morning flight to Munich, which we have to take quite often to go to some meetings and then fly back in the evening. I think this is a thing of the past. So I can't speak for the cars, but at least for the short-term business trips, I think that the past year has been a huge accelerator in dropping these kind of flights.
All right, thank you, Wolfgang. So thanks for your presentation again. Sorry about the technical hiccup in the beginning, and we are all learning from our experiences, and I think our learning curve has been quite steep in the past few months. This will take us to the second presentation for this afternoon, and it's about developing sustainable productions. It's a presentation that 3 institutions join, and we have 2 of our speakers here on the podium and 1 speaker with an online link to take us through this. The presentation will show us the development of a path, the development path of a system supplier for components made from sustainable raw materials. This process begins with the identification of product requirements, and it continues along the transfer to another industry and the development of components from sustainable raw materials. Finally, the development path will be complemented with the development of quality-assured, upscalable production concepts. We have 3 speakers, 3 companies from AC Styria cluster that will take us through this. There's Thomas Gimpel, who is online. Hello, Thomas, from Lean MC GmbH in Graz in Austria. He started in 1995 as a mechanical engineer in the automotive industry. He holds a bachelor's degree in mechanical engineering and a master's in business management. 2007, he founded Lean MC GmbH, located in Graz, and it focuses on project management and quality management to guide products from the first idea to market readiness. Our second speaker, sorry about that, here on stage is Wolfgang Knöbel, who is doing research and innovation at Weitzer Group. He has a technical background in control engineering and studied innovation management at the University of Applied Sciences in Graz. He holds a bachelor's degree in systematic innovation techniques and an economic master's degree in strategic innovation management. He was active in the automotive sector, where he was responsible for quality and test procedures in the field of test bench software. Later, he dedicated his work to the field of innovation management in academia as well as in co-entrepreneur. And he's with the Weitzer Group since 2020. And last not least, there's Thomas Kränke here on stage. He's a key researcher at Weitzer Energieinnovationszentrum GmbH. Now Weitzer, that's 1Z, whereas Weitzer Group is TZ. 2 different names, 2 different companies. Thomas studied process engineering at the Technical University of Dresden and received a PhD in the field of machining and processing of wood and wood-based materials from the University of Natural Resources and Life Sciences, Bodenkultur in German, in Vienna. He's part of the Weitzer Energieinnovationszentrum since 2019, and he's in the field of digitalization in the engineering and manufacturing process of wood and wood hybrid components, with products for the automotive, plant and mechanical engineering, consumer goods sectors. So please start off your presentation.
Thank you for your introduction, and it's an honor for me and my colleagues, Thomas Gimpel and Wolfgang Knöbel, to present here the project Woodcar and Carpentier. We are some parts of a big research group, and we can only present the results from the Woodcar and giving an outlook of the Carpentier project. But behind us is I told you before, it's a very big group. But in the beginning, you told us we want to see or to develop some new products made out of wood and wood hybrids. And so it leads me to my colleague, Thomas Gimpel.
Hello from the home office and out to the web space. Let's say the roadmap of this wood car project started in 2013 with a cross-sectional workshop related eco-design between the wood cluster, the Holz cluster Steiermark, and the AC Styria, the auto cluster Styria. And based on these basic discussions, we detected that there is a big potential in a new material, let's say new for automotive industry, related to take over component functions in a structural way. So we said, okay, there is a potential that defining the correct part function and bring it down via the property and part structure to a good process parameter. The motivation by taking this challenge to take wood as a material, as a new raw material, is to say, okay, we can use the high performances of wood by bringing them to new application functions. Also, there was a motivation to transfer properties of high performance material wood into function oriented process control system to make it on a good focus for the industrialization. And therefore, also we need a good quality along the complete production chains, means supply chain management. When we go to the next slide, we think it's important. In the beginning, in the introduction, we said there is an idea, but behind an idea, you need also to take care about the risks behind. And so we decided, okay, it's needed to make to accord to the DIN ISO 12100 to take care about the risk. And so on the systemic view, it's important that we have the conformity related to the law, that we ensure the essential health and safety requirements we have to meet, and sure also when we talk about industrial production, we have to protect also the manufacturer in terms of product liability. So means the goals for risk assessment is to identify the hazard possibilities, to reduce the risk as far as possible, and take the suitable protective measures to keep the risk away from the customer. Then to keep the roadmap of wood car project aligned, we agreed in the team that we always reflect to the so-called V model, which is part of the requirements management. And it's guiding us as product engineers to a logical linking between the product development, which happened interdisciplinary. And it gives all partners in the development process a good framework, and that we can also collect the mechatronical systems. At least the goals of the requirements management is to have a clear specification, to have a complete description of the use cases of the product, which are very important to define in the next step the complete KPIs, the key performance indicators, to have a complete parameter setting, not only during the development phase, so especially to keep the quality on a good level and the correct level during the serious production. Next slide, please. So we decided to go ahead with an innovation method focusing, let's call it function-oriented product development. and defining the big system into a capture of an analysis object and naming the function, and very important to give a structuring to the functions. And for example, the site impact beam, it's a principal illustration, which was also one of the so-called use cases in the wood car, is an object, the site impact beam as a component of the vehicle door. The function of this site impact beam is to absorb energy in the event of a crash, and the structure itself has to absorb impact energy within the component and redirecting any residual energy to the connection points of the vehicle cell. Means we have the complete vehicle. We detected the subsystem of the door, and with the smallest system and object of the site impact beam. So guiding us as a product engineer from the idea, making a site impact beam out of wood, to a very objective and controllable specification of the site impact beam with clear parameters for the following partners in the supply chain and in the production. Okay.
So thank you, Thomas, for your part of the presentation. And it will lead to the next part. So you have seen what we have done in the project Woodcare. We have shown that we can use the computer-aided engineering tools to develop new products made out of wood and wood hybrids. But what we have seen in the project is that we need some really special parts of the it's handmade manufacturing processes. And we see if we want to enter really to some big market like the automotive market, we need to go to an industry level. And therefore, we was selecting the next questions. And this was to go really from the handmade workshop to the industry level. And therefore, we need the function-oriented process control to homogeneous the parameters of the raw material in the wood processes. And this means, or what it means is, all products have a function, and this function is influenced by the properties and by the structure of this company, of this product. And we see that all our products need this structure because it's defined in the process, in the designing parameters. And the Young modulus is, for example, some properties from the raw materials, but what we cannot influence, but we have to identify how we can really modify this structure to be or to modify the Young's modulus. And so we want to watch about the parameters of the structure and of the material to identify this process parameters to adapt by the process this structure. On the next slide, you see by the principle of the function-oriented process control using example in the fiber angle. It means you, Thomas Gimpel talked to us by the side beam, and I was giving you now the example what it means if you look to the fiber angle of our veneer sheets. You have to control and to measure really how it's the fiber angle in your wood by the peeling process, and you have to adapt the cutting direction after the peeling process to get really the correct fiber angle and to adapt the process by the influencing of the wood parameters. But to go more in detail to the processes and to the production processes, this will be given by Wolfgang.
Thank you. Thank you for having me. It's an honor to speak on behalf of Weitzer Group. You all will know us on our famous brand Weitzer Parkett, where we produce world's finest parquet products. And we have developed a vision which is far beyond that. And this is named Finding Answers Made of Wood. And it is really an honor to be part of all these projects. And for us, Woodcar was a starting point. With Woodcar, we brought computer-aided engineering tools to the world of wood hybrid components. So yes, it is possible to create products already in a single part manufacturing. What does it mean? Cutting, fusing, pressing. So what it is the work of the well-known Carpentier. What you see here on our slides is simply, it is already live. So we are producing parts, we are working with the digital model, we're working in the real production process. There's a lot of handwork involved, but a lot of machinery, but we're not there where we want to be. And so Carpentier will be our next lever, where we combine the part function, the raw materials, where we bring the production processes in, and as already seen on this slide, we will have those two processes combined. What do I mean with that? There is a digital process you see here, and at the end of this digital process, you see the digital twin. And the second thing is quality and production stream. So at the end, it's not enough to have the digital twin. It is the real product we want to achieve. Single steps out of these processes are well known to our audience. It is the combination of these processes. It's the interlinking of these processes. Again, part function, raw material, and process technologies. With that, we start with our productions here on the left, with our requirements here on the left. We go over this industrialized process and end up with the digital twin plus the developed product. So for us, it's important to know that our audience knows that this is repeatable. We can do this after Carpentier within an industrialized process and without having the problem of a nature-grown material. We will use it without losing the touch of the nature-grown material. We will have a process which takes into these characteristics within our product, so that at the end we have for our customer a product plus a digital twin. And on the last slide, you see here, we will grow. After Carpentier, we will provide an even broader set of competences as we already have. What you see here is we have from the raw material to computer-aided engineering to simulation and so on, things which were not common in our industry years ago. Now they are. To our core focus field, wood machining, where we come from. And of course, there's room for further development. At the end of Carpentier, there has to be work done in standardization. There has to be work done in repair and recycling, but that's the nature of such a project. There are questions beyond the project. And with that, I will hand over for the last slide to Tom again for our outlook.
So thank you, Wolfgang. And let me show you the last slide and give you the outlook. What we will figure out with Carpentier, we want to have efficiency use of the raw material wood. We want to increase the yield of the production processes by the wood, to reduce the costs and so on. We are looking forward to see how really we can digitalization of the production process. And we want to make the digital twin of the product and of the production process. And so we want to reduce the safety factors for the new materials. And with this slide, I want to thank you for your attention.
Well, Thank you, Thomas and Wolfgang, for an amazing presentation. I've learned a lot in the past few decades about wood as a building material, but the last thing I was thinking about is wood as something that makes my car. So maybe first for the audience, if you want to send us questions through Zoom, please do so, and we'll try to accommodate them. However, if we miss to answer your questions because of time, you can send emails, and we'll have the email address ready for you later on, and always ask later on, and we'll pass it on. So what parts of the car would be your entry point? I mean, obviously, I think no industry is ready to sort of just turn over everything to your wood making process. But what part is the entry point, you think?
There is already an entry point. So this entry point is existing in the use cases which you see in wood car. So there is a side beam where we say, okay, never one thought that it would be possible to exchange that from aluminum or steel to wood. What is important for us is the question, does it make sense to create everything out of wood? That's not what we're saying. We say wood was already once there, ships, cars, airplanes. If you see a Morgan running on the streets today, it's a wooden car. So wood is there. Wood has its place in structural materials and structural components of the future. It is necessary for our planet. We can make it lighter. We can reduce costs for our planet. So we will have certain parts where we pick them out, where we are learning through carpentry, and we will bring wood to the structural part where it makes sense.
If you would look at a time span, like say 15 years from now, what would be the percentage of a car's material that are made out of wood?
We're thinking more than 5% we can really change, and we have it in all different parts of a car. So it means we are not really fixing now that we want to be there or somewhere else. We are really open to go the questions and to ask really where we can use it to make it really make sense to use wood as a lightweight construction material, like for example by the battery housing or something like this. I hope I answer your question.
Well, you're very polite towards the existing industries who supply the materials. I can understand that, but that's fine. I guess we all, when we come from research and the first steps, are careful not to overpromise. So better over-deliver and under-promise.
Yeah.
Yes.
Well, thank you very much for this session.
Thank you very much.
It is time to move on to the next session, and we'll see you later in the break. The next session it's about the Alp.lab project. The Austrian test region Alp.lab is the one-stop shop for testing of automated driving functions and whole vehicles. Of course, if we want to develop autonomous driving, we need areas where to test them and find out where they crash and where they don't crash with no humans involved. So this test region, Alp.lab, covers comprehensive testing opportunities, both on private and public test sectors, and as well as in-house data management and data broker systems for collecting and offering training data for artificial intelligence. Now, in this session, I welcome Gerhard Greiner, who is Managing Director of Alp.lab GmbH. He holds a master's degree in computer science from Graz University of Technology, and he is committed to rethinking our mobility in new and sustainable ways. His experience in digitizing and transforming the media and telecommunications industry in the early 1990s, different field, but now with telecommunications growing closer to the car industry again, he will help to turn car driving into a connected, cooperative and automated mobile experience. So the floor is all yours.
So thank you for this kind introduction, and thank you SFG for having me here today. So it's so great to be on stage live. So this was what we have missed all the months ago. So yeah, let me start with the first picture. this might be, oh, yeah, it is here on the right screen. Yeah, yeah. So let me start with a motivation and a picture from the year 1921. So 100 years ago, there was an article in a German newspaper saying that the vehicles, the cars are all almost perfect. There is no improvement necessary. So why should we do anything else? Just use the car. And maybe this was the first time when we were talking about self-driving cars in the sense of you can drive your car by your own, because till that time you had to have a chauffeur that was driving the car, because you had to change the oil and it was very dusty to drive this car. So this was the first time to drive the car by your own. So let's go back to some 1810, when Napoleon had the idea, how can he feed his troops? And he set out the price, and the result was the can. So someone has developed the idea to put food into a can, but it took several years until 1855 that there was an instrument developed to open the cans, because before these soldiers had to open it with their knives, and it would never have been that successful if you need an additional device to open a can. Just imagine if Red Bull would have been that successful if you need a special device to open a Red Bull can. So never, never this business model of that Red Bull would have been that successful. If we come now to the automotive industries, the Society of Automotive Engineers have defined 5 levels from level 0 to level 5 of automated driving cars. And level 0 is without any support, without any additional function that is supporting drivers, and up to level 5, that is something like a robo-car. So there you don't have a steering wheel in the car, and you just sit into the car, and the car will bring you to the destination you have selected. At the moment, we are somewhere in between the level 2 and 3, because that is the level where the car takes over responsibility of driving it. But even in the level 3, the person that is sitting in the car is responsible for safe driving these cars. So function 4 is that there are several functions, or level 4 is that there are several functions already automated. So for example, if you drive on the highway, so there's a highway autopilot that is steering, braking, and accelerating the car by their own, but you have to take over in some critical situations. When we think about how to develop the cars, a car should be, an automated car should be as good, at least as good as people are driving cars. So this is always the guideline when you develop an automated driving car, that it should be at least as good as people, as human drivers can drive it. But in addition, we also have to take care that the SDG goals, the Sustainable Delivery Goals, are also fulfilled with the self-driving car. So it should be zero impacts, accidents, deadly accidents on the road, and it also should take care of our environment. So this is also what we want to achieve with self-driving mobility. So if we look further, what's going on at the moment? And it all started with the idea from mainly IT companies that you just put some additional sensors on the car. So if you think back to the Google car, they just put a sensor, a LiDAR, a laser scanner on the car, and then they said, oh, it's about software. You have heard at this point of time, software eats the world. So they thought that additional sensors on the car and the car can drive automatically, and the problem is solved by software. There are several approaches to mobility with self-driving vehicles. So for example, the robocar, this is an experience. We also have a robocar team here at the university in Graz that is very successful in this robocar competition. So there the driver is not the hero, there the software development team is the hero if they can drive with their robocar as fast as or faster as the other ones. So it is definitely a competition with robocars where no driver is sitting in. So they all have the same cars, and it's only the software and acting with the sensors is the way the cars are winning here. Then we have new kinds of mobility. So if you think on public transportation, so there will come up a new kind of on-demand transportations. And these are all pictures from the press releases from different companies. So ZF promoted a car that is sometimes called a people mover, where up to 7 or 12 people can sit into such a self-driving car that picks you up at a place and brings you to a destination. So this is a replacement and a new kind of mobility that will support the public transportation and will bring new business models to cities and also the areas around cities. More flexibility is the goal of that kind of mobility services. Then there are also self-driving motorbikes. So for example, if you go on the web, you can see that in that fantastic bike, and this is not an April joke, as Google has done it with a bike, with a bicycle some years ago, that definitely can drive automatically. Then there are total different new kind of vehicles. So for last mile delivery, as Amazon and other companies are doing at the moment, to support the delivery to your home. So that kind of vehicles will deliver your parcels at home for the last mile. And then at the end, logistics, so that also will change, that you have some truck that is pulling some containers, and this will also change our kind of mobility. So if you talk about self-driving cars, so what they need, you have this sense, think, and act. So it is necessary to get information from the car, that means from sensors that are mounted on or in the car, and also to get information from some infrastructure sensors. So at the first, and when I started to work for Alplab, so everyone was talking about, yeah, you just have to put enough sensors on the car and this will also solve all problems. We have learned now that we also need some information from sensors from outside. So special crossings or intersections should also deliver some information into the car. So we are talking then about vehicle to X or infrastructure communication. That is so important. And then you also have to think, as you mentioned it, about telecommunication. So what is the network that is delivering in time, without any time delay, information into the car so that the car can act in the right way? Then we come to think. The first idea was you just put sensors on the car, then software eats the world, and the problem is solved. But now you may have heard also artificial intelligence eats the software. So there's a total new approach on how a system with software is working. And then here comes the artificial intelligence and machine learning into the game. And learn from the experience from other cars to move or to go very, very good in the car without any accidents. And then you have to act. So all the information that comes from a system to steer, to accelerate, to brake the vehicle, their hardware has to act. So what are we doing at AlpLab? So AlpLab, we are not a company that is doing research or development of self-driving cars. We enable safe and secure testing of automated cars and automated mobility. So our goal is to test the sensors that are on the car. And here on the left side, you see our Spider. This is a mobile hardware in the loop platform. That is, before you develop a prototype of a car, you already can test with this Spider the sensors that will be used afterwards. So hardware in the loop means that you can already test the position of the hardware. And sometimes we put the front of an Audi on this Spider so that we can, we will have a look how the sensor is working in this front of a vehicle. Then we need information from outside, from an intersection. And we have installed LiDAR, these are LiDAR sensors, radar, and optical sensors on some 10 crossings and intersections in Austria, 2 of them in Graz. So where we gather all that information from the intersection and can show and can deliver that information into the car, or also can see from a bird eye view how the automated cars or the traffic generated from human drivers is working, because automated driving cars should behave like human drivers. And there we are collecting data from the real human driving. We then put that information into a digital twin, and together with one of our shareholders, UNERM Research, we have generated a digital twin of the intersection so that we can put the movement of the vehicles, of all the objects, also passengers and bicycle drivers, into that digital twin to do some simulation. So we are coming then to simulation. So that means that all that information we are gathering can be used to simulate automated driving systems, functions, and software. And here on the left picture, you see that kind of simulation that is used by the OEMs and tier ones to simulate real traffic in the computer. The second picture shows, just go back and then once again, start movement. You see testing on a closed proving ground. So here we have some overrunnable robot platforms where we put vehicles and also pedestrians on this robot platform, and we can use real cars in combination with that dummies, if the function of the vehicles works right. And then we go, if that works, we go on the real road, on the highway, for example, to test this function again, if it definitely works. So now let me come to an end. So we will be your partner for cooperative, connected, automated mobility. So our shareholders, you also find on this slide, are from the automotive industry, AVL and Magna. And from the research, our shareholders are Technical University of Graz, Virtual Vehicle, and UNERM Research. We are supported by the Austrian Ministry for Climate Action through the promotion agency FFG. And you find my contact details, and I would be happy if we will be your partner, and especially as we have heard in the presentation from Wolfgang before, if you need some data for artificial intelligence, we are collecting a lot of data on our crossings, on our intersections of real traffic, and we would offer that traffic and all that scenarios and maneuvers that are happening in the real world for the simulation to feed your artificial intelligence algorithm and to learn how traffic works in Austria. So that is my part, and if there are some questions, I will be open and happy to answer.
Thank you, Gerhard Greiner. Interesting insight in how we move along. Here is a question I have: some time back, this has been a science fiction idea, as many things. And when maybe 10, 15 years ago, Google, which is now Waymo, started, it gave us the idea that the car we have, or the new car we have, will just drive anywhere. In reality, that might be too challenging. So is there, for instance, I live in a street which is a pedestrian zone where bicyclists and cars can pass through, and I think it would just stop there and never move again. Whereas on the highway I came down from Vienna, basically I see trucks lined up on the right lane and regular small cars on the left lane, and they more or less move in union. So is it a development where we need to rethink about what autonomy means in certain areas rather than have this science fiction fantasy of being autonomous anywhere?
So I think that this idea of buying a robo-car by your own as your private car, so that will be far in the future. Although in the next year, some of the ADAS function, these advanced driver assistance systems, are mandatory for the upper class of cars. So if you buy an upper class car next year, so that will have this automatic braking system, a lane keeping, and also steering support as a driver function. But for a real autonomous car, you always have to ask where it should work autonomous. So on level 4, specific functions are defined as an autonomous. So for example, parking will be one of the functions that can be autonomous in a few years. Some cars already are offering that. So you just go to the airport, you leave your car, and there will be some autonomous valet parking, and the car will look for his parking slot and will drive there. And when you come back with the communication, it says, okay, come back and pick me up. But you're right, it will not be automated everywhere because this is too complex. But as in addition to public transportation, that kind of people mover as an on-demand delivery, where it doesn't make sense to have public transportation all over the night, but you can then order a people mover to move people somewhere. That will work, and that will come within the next few years.
So we should recalibrate our fantasies in a way.
Yeah. But and I think so. You really realize that the brain that is steering and doing mobility is definitely an amazing machine. It is really hard to have this.
Right. Thanks for this encouraging comment at the end of our first part of the session. If you have, there's my camera. If you have questions, then please send them to mitra@acsteria.com. I'll spell that out for you. It's MITTER@acsteria.com. And we'll repeat that address in the later parts of the session. Again, if you want to use the chat function in the next part, that's fine too. So we are having a break now. Enjoy your coffee. And of course, you maybe have had your coffee and we couldn't see you. But be back, please, at 3:45 p.m. for the next presentation. Thank you. Welcome back after the break to this Future of Mobility session at the Global Innovation Summit in Graz, Austria. I hope you had a good break, and we'll move right on with our topics on this next presentation, which deals with the potential of fuel cells and hydrogen for future mobility. Electromobility with fuel cells and hydrogen offers significant advantages compared to battery, which are very heavy, as we all know. And these advantages might be easier to come by first in heavier vehicles, higher loads, special applications. Our speaker, Martin Agarwal, will present exemplary projects with applications, and he will show them in passenger cars as well as buses, trucks, special vehicles. And he will analyze these configurations and summarize them for our understanding. Martin, who is next to me, is a researcher and project manager at High Center Research GmbH, and that's the first Austrian research center on hydrogen. He's an expert in the field of fuel cell and hydrogen tank systems developed for mobile applications. He holds degrees in industrial engineering and management from TU Wien, the Technical University Vienna, and mechanical engineering from Graz University of Technology. So, Martin, floor is all yours for the topic.
So, thank you very much for this short introduction. So, I'm project manager at the Hydrogen Center Austria, and today I'm honored to introduce you into the important topic of potentials and examples of electromobility with fuel cells and hydrogen. So, a short introduction into our company. So, we are the only extra-university research institution in Austria, which we are exclusively concerned with hydrogen technologies since the year 2005. So, we are located at the TU Graz campus, and in total, we are 160 researchers in the field of hydrogen, and exclusively 44 exclusively concerned with hydrogen itself. So we are performing innovative research and development projects in an international network with academia, and regarding the production, distribution, storage, and the application of hydrogen itself. We have successfully finished more than 70 projects, and what sets us apart amongst others, other companies or other research institutions, is our state-of-the-art testing facilities, with a value of more than 50 million euro. So we are covering all fields of expertise, including engineering, simulation, testing and education of hydrogen, and especially technologies like electrolysis, gaseous storage systems, fuel cells, and so on. Moreover, we are supporting the educational issues in cooperation with the TU Graz by supervision of academic theses, and by offering hydrogen-related lectures. Our company structure, our stakeholders are the TU Graz, the Magna, the FVT, and OMV. Okay, so our vision at High Center is a hydrogen economy as a solution for renewable energy systems. So renewable green energy like solar, wind, and hydro should be fed directly into the power grid and should be used in all applications like mobility, households, and industry. This path is undisputed the highest efficiency, so it should be used directly. To implement a CO2 neutral society, our energy production must be 100% renewable. But there's one major issue. So the volatility of these technologies, like sun is not always shining, wind is not always blowing, we need the energy during the whole day, during the whole year. So the solution is hydrogen. During times of overproduction, so the production is higher as the consume, we can produce hydrogen via, for instance, electrolysis and store it in gas storages. Afterwards, we can use it and distribute it directly into the mobility sector in households and industries, or convert it back to electricity via fuel cells. So, hydrogen can be the solution for a CO2 neutral society, and one important message I want to give you is that we need to make sure that green energy gets into our vehicles, and hydrogen is the key for it. So let's have a deeper look into the zero-emission mobility technologies. There are three main technologies available. It's the battery electric vehicles, the fuel cell electric vehicles, and other powertrain technologies, which are based on bio and hydrogen-based synthetic fuels. Now the question is where or in which applications to use these technologies. We focus on vehicle weight, daily mileage or average mileage per day, and costs. So the diagram, which you can see in my slides, gives the answer. We see the weight on the vertical axis and the mileage on the horizontal axis. So small cars with low weight and low daily mileage are located in the left bottom corner. And heavy applications, heavy vessels or airplanes are located in the right upper corner of the diagram. So based on a cost analysis of these different technologies, there are the different colors in the diagram show the cost break-even point of each technology. So at a certain point of a vehicle size, the costs for the battery itself are higher than for a hydrogen and fuel cell system of zero-emission technology. So in comparison, a battery electric vehicle makes sense for smaller cars because it has the highest efficiency, is suitable for short driving ranges, and it has a long charging time. On the other hand, for bigger cars, even heavy-duty vehicles, the fuel cell vehicles are suitable because they also have a high efficiency, have long driving ranges, and have a short refueling time. So let us use batteries where they are suitable and fuel cells where they are necessary. Okay, and if we compare different drivetrain technologies, we always have to make a look into the whole life cycle emissions of these technologies. So I don't want to get too much into detail of this diagram, but this diagram shows basically the greenhouse gases in gram per kilometer, gram per kilometer. So the bars, different colors, show the different emissions at a different lifetime of the car. So the green bars show the direct emissions during driving. The red the red bar section of the bar shows the energy supply emissions, so the production of the fuel, the vehicle production, and the battery production if there is a battery on board. So gasoline vehicles have an average emission of around 160 gram greenhouse gases per kilometer. Diesel the same, and also like plug-in hybrids or CNG cars. So if we compare it now with the life cycle emissions of battery electric vehicles, we can see that the energy supply, that we don't have any driving emissions because they don't have any pollutions during driving, but the energy drive for supplying the energy, so energy supply emissions, are highly dependent on the electricity production. So if we have a look, for instance, if we produce the energy with renewable energy, the emissions also of a battery electric car are very low compared to a combustion engine. So, and the last technology, the fuel cell electric vehicle, if we also have a deeper look into the renewable energy supply, so if we supply our car with green hydrogen, the overall life cycle emissions are even lower than the battery electric vehicle because of the battery production emissions. So with fuel cell electric vehicles, we have a high potential for reducing our whole life cycle CO2 emissions. So in the following slides, I want to give you a more detailed insight into the technology of the FCEV cars. So a FCEV powertrain consists basically of a hydrogen tank. In passenger cars, we store hydrogen at around between 300 and 700 bar, gaseous hydrogen. We have a fuel cell in it, which converts hydrogen into electricity and water. And we have a battery for boosting and recuperation and electric motor, which converts the electrical energy into kinetic energy. In the right bottom picture, you can see the Hyundai Nexo. It's already the second generation of a fuel cell electric vehicle, and it has a driving range up to 750 kilometers. So, if we speak of the fuel cell itself, it always needs some components around because a fuel cell, the operation of a fuel cell the principle is easy, but in reality, it needs much more components because we need to supply hydrogen and oxygen out of the air with the sufficient mass at a certain pressure, with the right temperature and right humidity. So we call these components balance of plants components. And you see the fuel cell system of the Honda Clarity. It was from 2018. It looks like a conventional ICE combustion engine. It has the same packaging space, so we can integrate it also quite easily into normal passenger cars or other applications. And at the right bottom diagram, you can see a schematic of such a fuel cell system. So one step deeper into the technology. So now when we come to the fuel cell itself, it's an electrochemical cell. There are different types of fuel cells regarding the reactants, like hydrogen, then different efficiencies, different operation temperatures, and in the mobility sector, we use due to the dynamic behavior and good efficiency, the proton exchange membrane fuel cell. So the overall reaction of these fuel cells is hydrogen plus oxygen is water and electricity. A single fuel cell, which is just around 1 to 2 millimeters, has a 1 to 2 millimeters thickness, converts only a relatively little energy, around 200 watts. But in a car, we need around 100 kilowatts. So we need a serial connection of these cells, which leads to higher electrical power output, and we call that a fuel cell stack. Okay, so the other component which is in the car, or we need in the car, is the storage of hydrogen. So I already mentioned we can store it as gaseous in a gaseous way, or there are different types as well. So compressed gas, as I mentioned, and the second one is the cryogenically liquefied hydrogen. Hydrogen gets liquid at around minus 253 degrees. So we also can cool it down, and then it gets liquid. And in other compounds, like with physical or chemical compounds, with adsorption and absorption on or in different materials. So for the mobility sector, I only want to compare the first two technologies, the gaseous and the liquid hydrogen storage systems. And I only want to compare these technologies which were the pros and the cons. So the liquid hydrogen storage system, at including a tank, including valves, has quite high energy densities compared to gaseous hydrogen. As well, the gravimetric, also the volumetric energy density. So with the same, we can store more hydrogen with this in the same amount of system mass. So the energy density, or the energy demand to produce liquid hydrogen or to compress gaseous hydrogen to 700 bar is the energy demand for gaseous hydrogen is lower. So we don't need that much energy for to compress hydrogen. The technology readiness level is also much more well established for gaseous hydrogen. So it is, we see also most of the cars with the fuel cell electric vehicle have a gaseous hydrogen storage system on board. Important are also to compare the system costs, and we see there a higher potential for the liquid hydrogen storage system, because the gaseous hydrogen storage has a high material input, because we need to use carbon fiber. We need to make it light, we need to make it very stiff, and the strength must be very high. And the winding process for this carbon fiber process cannot be much more accelerated. So we have limits in our production technology. And that's the big difference to the liquid storage. Okay, so and also, of course, the infrastructure availability is higher with the gaseous hydrogen. So for the next years, I'm sure we see a lot more gaseous hydrogen storages on the streets than in the cars than liquid. But we have a higher potential. We have a high potential to use also the liquid storage. Okay, so let's come back. Let's get to the application examples. I want to give you some examples in which we, the Heisenter and other companies, demonstrated successfully the fuel cell technology, and starting from small logistic vehicles even to big vehicles like trains. So I want to give you some examples. The first project, which was also funded, governmental funded, is the ELOC biofleet. We replaced the industrial battery electric industrial truck by a fuel cell range extender with a hydrogen pressure tank. The hydrogen in this logistic company was produced on-site by decentralized reforming of biomethane. And it was the European's first hydrogen indoor refueling infrastructure. And we also won the Energy Globe Award for that. So yeah, it was a very, very interesting project. And it is possible even to convert or to replace such small vehicles into fuel cell electric vehicles. So the next project I want to give you an overlook is the HySnow. It's still ongoing, and there are a lot of companies also involved, which I can't mention now. You see it on the slide. So the target of this project is the decarbonization of the winter tourism by hydrogen-powered fuel cell snowmobiles. In this project, we constructed the first hydrogen filling station in an alpine environment. So the filling station is located in Upper Austria in a skiing area in Hinterstoder. It is direct coupled to a photovoltaic system and electrolysis system. So we produce the hydrogen on-site, green hydrogen. The hydrogen is used in a refueling station, which powers which powers fuel cell electric snowmobiles, which we also developed in this project. And these snowmobiles are operated under real operating conditions, and yeah, are still under operation. So we see on the pictures the refueling station in the snowmobile, the snowmobile driving or riding on the snow, and the photovoltaic system on the garage. Yeah, another project is the KeyTech for EV project. It was a conversion of a passenger car, a WV Passat, converted into a FCV powertrain. The overall objective was to implement the CO2-free powertrain, and with focus of energy efficiency, cost efficiency of all components, guarantee or provide a high driving range and good drivability. Yeah, let's get even bigger now. So think bigger, like the project HyTruck. This project we tried to develop a zero-emission powertrain for the commercial vehicle market. The powertrain should be modular, with different power outputs from 100 kilowatts to even 300 kilowatts. The trucks should have a driving range over 1,000 kilometers. Even the lifetime is a very important in this sector, and we want to get it up to 20,000 hours operation hours. So maybe a short excursus to again to a technology application comparison. So if we have a truck, a 40-ton heavy-duty truck, with an ICE combustion powertrain, we have around 10 tons, which weighs the powertrain itself, the vehicle itself, and we have a payload of around 30 tons, which are available to transport goods. If we convert it to a fuel cell truck, we have on top 4 tons of powertrain mass, which leads to a payload of 26 tons we have left. If we convert it to a pure battery electric vehicle truck, the powertrain weighs around 8 tons more, and we only have around 12 tons left of payload. What does that mean? We need 2 times more trucks and 2 times more traffic on the streets to transport the goods from A to B. And even if we see, or if we have a look at the efficiency of these trucks, it's for sure that the battery electric truck has a high efficiency at around 85% of efficiency. A hydrogen truck will have around 60%, but if we have double of the traffic, we can multiply these efficiencies of a battery electric truck, and in total, the battery electric truck has around 40, or the double of traffic has around 40% lower efficiency compared to a single fuel cell electric truck. So again, my statement: use batteries where they are suitable and fuel cells where they are necessary. Okay, last but not least, we also tried to decarbonize the entire rural bus fleet of Graz. So there's a demo fleet with 7 battery electric vehicle and 7 fuel cell electric buses. We built up a 350-bar refueling station at the bus center in Graz. We tried to modeling the ideal technology split between the BEV and FCV buses, and we are developing a novel and efficient electrochemical and mechanical hydrogen compression technology. So the last project I want to give you a short introduction is the development of the world's first narrow gauge railway, powered by green hydrogen. This project takes place in the Zillertal. It's in Tyrol. And there we build up also a hydrogen production plant, which is based on electrolysis and powered by hydropower. And also there is also, like the previous project, also the whole ecosystem, the whole hydrogen ecosystem is necessary to implement these technologies. So the last keywords I want to give you on your way is: hydrogen is the key role for the expansion of renewable energy. PEM fuel cell technology can be used in all vehicle classes. This technology is resource friendly. We have a high recyclability rate, and it has the lowest CO2 life cycle emissions with green hydrogen, of course. The technology is fully developed and safe, and batteries were suitable and fuel cells were necessary. So thank you for your attention.
Thank you, Martin Agarwal. You've taken up all the time there is and some more. So we won't be getting around to questions, although I would have quite a few. But let me remind you again that you can send questions to Mitra, M-I-T-T-E-R-E-R @acysteria.com later on or right now, and we'll pass them on to the speakers. So we'll move right on to our next presentation. Thank you again, Martin. Our next presentation is about safety and sustainability by design. And we have seen quite a few developments that showed us that it's important to address safety and sustainability right from the beginning of a design process in every product. And too often we see products where it's second thought and it's difficult to come up with a safe and sustainable solution later on. There is BioNanoNet, who will present us with its SSBD concept. They're calling it, it's the safety and sustainability by design, which helps and guides companies when meeting efficiently future market requirements in terms of sustainable innovation. Now for this, I would like to welcome online by link Andreas Falk, who is the CEO of BioNanoNet Forschungsgesellschaft. They have a short handle that's BNN. And Andreas, he has studied medical and analytical technologies and business administration and has been a partner in more than 40 research fields, international research projects in the fields of nanomedicine and safety, innovation and sustainable development. And there he has contributed a lot of oral and poster presentations at conferences, workshops, scientific activities. So please welcome Andreas Falk online. And the floor is yours, Andreas.
Thank you very much. I hope you can hear me well. It seems
Yes.
everything is working perfect. Yeah, welcome to my presentation. I think that future of mobility is perfectly fitting for this talk. And thank you, of course, to the AC Styria for organizing this session in the frame of the green transition part of this conference. Thank you also, of course, for inviting me to present the safety and sustainability by design, which is more or less a must-have towards sustainable innovation. So following the talks about the sustainable production, it becomes more and more visible how often we could have seen now materials and processes that have been mentioned throughout the talks about the future of mobility. By this reason, I totally feel with BNN, which I represent as the CEO of this research organization, that we are placed really in the core of these businesses with our approach to integrate these aspects of safety and sustainability already from the very early stages of the design phase of any technological development. When speaking about safety from my side, I do have the safety in mind, safety of materials, processes, and products for humans and the environment. So this focus might be a little bit different of, let's say, car safety, but that's definitely a separation or differentiation. When speaking about the sustainability, we definitely address all three dimensions of the sustainability. So the economic sustainability, as well as the social sustainability and the environmental sustainability. So as you see on the slide and the start of my presentation about the safety and sustainability by design, I will more often talk about SSBD because it's just nicely abbreviated. And I think it is very important also to mention that, as you can see from the name of our organization, the full name, BioNanoNet, that we started this development of this SSBD concept in the field of nanotechnologies. Today, I guess all of you are aware, some may be already vaccinated, others not, that nanotechnologies and thinking about all this COVID pandemic around us and the role of nanomedicine in all this part, using nanomedical innovation that are safe. This is one of the approaches who made the humanity winning this race towards a vaccine. And I think society recognizes now already that this enabling technology is something really, really useful for all of us. Okay, this one, as a matter of fact, that nanomaterials are parts in maybe most of the mobility relevant products around, for example, the lightweight materials. There is a perfect fit also into this session. The concept that we offer for the technology development, it was created to pave the way to the market for nanotech-based products at the beginning. as mentioned earlier, if you remember the talk of Wolfgang Kienreich, one of the drivers for the changing of minds of the people is, as very often, regulation. So to speak, to successfully commercialize any product, need some smart dealing with regulations. Of course, on the other side, also the protection of your inventions with patents, but that's just one of these parts along to the way to the market. Challenges for the technological development arise at the beginning when the more or less major methods need to be reproducible and of course scalable to get to a higher bench and to get to real high throughput production, which means that if these points shall be tackled from a right way, it often needs a kind of multidisciplinary research and also to integrate at this stage groups that can offer some kind of analytical methods to gain some data about the safety of the processes, the products, materials, which you then have to show the evidence of the safety, like in safety data sheets and so on, to be able to at the end build some trust and confidence in the public, and of course some secure position for the industry that there is not coming up any future regulation that will stop having these products on the market. So we started the development of this SSBD concept based on a classical chemical risk assessment approach. In that case, looking on, okay, the hazard, identify the hazards, characterize them to gain some real data about what could be associated from the hazard side, look into the exposure of humans and the environment, and to find out by having this equation, hazard times exposure, to just get a kind of risk assessment at the end. It's more or less an old scheme, but still valid. From that point, the safe by design or safety by design concept went forward, and we tried to tackle the challenge that are present. On the one hand, by the technological innovations, and of course, in the field of the health and environmental risk assessment, which means that on the one hand, we do have a nice technological push forward, but on the other hand, in most times, health and safety is lacking behind. And first there comes something up, and then later on people think about what could be caused by this. Due to the fact that the innovative developments are, as said, ahead of this, any suitable kind of risk assessment tool or framework, there is a cost of a gap between these two parts, between the innovation and the safety assessment. So for reducing, on the one hand, this gap, on the other hand, to reduce the uncertainties, either for the people out there, but also on the other side for the industry about their inventions, and furthermore, to minimize the risks to humans and the environment, this safety by design concept was created, and starting at a very, very early stage of the technological development. Of course, as you know, or you might know, this concept is definitely not new, but its application needs quite a lot of effort to tailor it to the specific needs of our customers. What is now the second S in the name? So SSBD is the safety and sustainability by design. Since several years now, we do the integration of the sustainability aspects into this concept. And as you know, safety is, of course, one of the aspects also addressed in the sustainability field. However, we do it, as you can see here on the slide, along these 3 lines, having in mind the people, having in mind the planet, but also having in mind the profit. Numerous organizations and initiatives have taken this up recently in their portfolio, as it has become a real hot topic. And as you know, the UN Sustainable Development Goals give a kind of cornerstone to all of those activities. Additionally, the investments coming from the European Commission into the programs like the European Green Deal actions show first signals that it becomes visible that there is an urgent need to act now instead of postponing this important action. Beyond thinking about the technological excellence, about the features and the properties that are there, we wanted to develop a concept on SSBD that definitely adds value to the entire process in the technological upgrade. In this case, we said the assessment of different settings and options during the innovation process needs to be done with the clear aim to design materials, processes, intermediates or products as safe and sustainable as possible, but also keeping in mind and maintaining the technical specifications, complying with regulations, anticipating also future regulatory requirements, and what I think is also relevant for the business-oriented minds around us, keeping the costs of the implementation of these measures as low as possible. So within that work we do perform, our aim is to find the best solution tailored to the specific needs and thus to support innovation, not to hinder it. On that way, we have a close look on the one hand on the health and safety issues, including humans, workers, consumers, environment, and as a key part to integrate also the regulatory and standardization aspects. You see the word of regulatory preparedness. With our special position in the European ecosystem in supporting relevant groups like the European Chemical Agency or the OECD or the WHO, there comes up a good option also to anticipate which kind of regulations could come up in the future. And by this, we are trying to prepare our customers and our project partners in a way that they are definitely prepared also for so-called regulatory trends, and that they do not face a late development failure due to upcoming later on regulations. Furthermore, of course, we do address the technological ingredients like the materials, the processes that are needed for technological innovation, and of course continuing with all these process related aspects. To make it more easy to follow, I tried to put some special points that we do consider in the way on the plate. So as said before, this concept we do offer is tailored to the customer specific needs. This might be in terms of materials to look into either substitution, so to use just different materials, modifications to, let's say, give additional or a different functionalization on the material, and of course looking into the reduction and maybe in the efficiency and efficacy from the material side of view. What also is definitely an important part here is that the recyclability is already taken into account from the beginning to enable at the end of the life of this material or the use of this material that it can continue within the circularity thinking, and that we can come towards a real circular economy with these processes and products. Of course, what is also a core part of our work is that we do look very much into the processes and products, because they get a very special attention in terms of the potential exposure, of course, in terms of, as said before, the circularity, that it's not a one-time use and creating additional waste, but by this also addressing already this kind of end-of-life scenarios, durability scenarios that feed also into the ethical and social aspects of the sustainability, how we address it in our concept. So along the implementation of the SSBD, we definitely are aware of boundaries. This could definitely be the performance parameters. So if you have in mind your product or your process, which you drive in your company, you might think of seeing it critical to implement a kind of safe and sustainability by design concept. But on the other side, we are going together with our customers to set milestones that make very clear that the envisaged performance parameters need to be addressed, and at the end that it's at least on the same performance level as it has been before. So each of those listed boundaries here we do see as challenges that we want to overcome, and normally in our projects and in our work we do overcome them by addressing them already from the beginning. So we set the points together. Where do we start? What are the steps? Who can do what at that point? And of course, the end point, or also called the milestone, is our targeted aim in our implementation and integration of this customer or project-oriented agreement. Which brings me to another very important part of this work, and that's our international collaboration. One of our success factors, I would say, is our multidisciplinary collaboration within research and innovation projects funded by the European Commission. Like here, you can see on the screen, Sabidoma, Safe by Design for nanotechnologies, Harmless, Diagonal, High Accuracy, Next-Gen Microfluidics, and Nanopad as some of the projects just to be mentioned here and to be acknowledged. On the one hand, in this project, we are working on the SSBD concept refinement to further develop existing tools, to set indicators and make the approach suitable for nano-enabled innovation. But also, and this was, if you remember at my beginning of the talk, we come from this side. So nano is more specific than, let's say, non-nano, which makes it easier to tailor our SSBD to a non-nano product or process compared to the other way around, where you need some very specific skills and knowledge to be able to tackle also the nano-sized materials and processes, which means each of those concepts is definitely applicable for non-nano, and to be honest, it's even easier compared to the nano side. What we see in the implementation of the SSBD is that in different sectors, there are similar needs, and there are definitely similar points to be addressed along the implementation of this concept. What I would say you can see here from these three projects that I mentioned, like High Accuracy, Next-Gen Microfluidics, and Nanopad project. These are technologies which have in their consortium definitely key technology providers also for the future of the mobility. Like, for example, printing technologies, very high accuracy printing technologies, of course, the next generation of microfluidics and sensor systems that definitely can be very important for mobility. And Another one in the field of quality assurance and looking into online and inline monitoring, all the process analytical technologies area, like it is addressed in the NanoPath project. Finally, I want to come to the take-home messages. I think that's quite important, that you can take something with you, and if you come back later on, looking back to the Global Innovation Summit here, that you say, okay, you have got something out of it from the talks. I want to put in your heads that the integrating of safety and sustainability aspects already in the earliest possible phase of the technology development is definitely a key to the breakthroughs in the innovative sectors. BNN, with our SSBT approach, is able to support you to find the best solution, from definitely having the valuable support of experts from our network around us, that we can also offer the combination with the multidisciplinary cooperation, because we do have quite a lot of very, very strong partners that would fit to specific analytical or technological needs. And of course, that's not all done from my side. And I'm very happy that I do have an area leader for all our design for technology development work. That's Susanne Resch. She has also a background in the pharmaceutical side, as she has done her studies on this field. And definitely, if you are interested to collaborate with us and to find out what would be a best solution for your specific use cases to integrate safety and sustainability in that, we are more than happy to be connected with you, and that you come back to us, either to Susanne Resch from my team or to my contact. And with this, I'd like to once more thank the organizers for this very nice opportunity to reach out to you. And of course, I want to thank you for your kind attention. I could not see you, but I hope you had a good time this last 15 minutes. And definitely, I'm looking forward to any questions you might have. Thank you.
Thank you, Andreas Falk. I do have a question actually, and it's a takeaway from your message. I wonder if the safe and sustainable by design thinking is not actually a large or big challenge to the startup culture, which goes by the slogans of break things and fail fast and no regulation. I mean, if we look at issues like mobility, like Uber and Lyft, like Airbnb and others. So, do you think we need a change in the startup culture that brings a lot of innovation?
Thank you for that very important question. We know that nowadays startups need to think sustainable. And of course, if you limit this down to say, okay, the only thing I want to have in mind is making profit with whatever I do, then it per se will be a certain kind of failure. I think to address in the mind setting of a startup already from the beginning, to show to the outside, to the market, ladies and gentlemen, we are safe for you, we are sustainable for the environment, and we care about the next generation with our technological development. This shows, on the one hand, the social competence, and on the other hand, gives additional drive. We are in a mobility session, so it's definitely a drive or a boost for these startups to tackle this already from the beginning of their development. So it's not a contradictory, it's definitely a complementary part, which gives them a much better position on the market. And we do have one area in our organization, which is called the innovation support area, driving a valorization program with the young entrepreneurs, which definitely enables them, and we have already the success stories, that they can reach out to the market with having clear arguments in their hands that they are on a safe and sustainable way forward. So this is one of the future aspects I would appreciate if it's more and more taken up, not only because we do it, but because it will save our future.
All right, thank you again, Andreas Falk. And with this, we'll take it to our next presentation, which is, and I hope he won't mind my characterizing it this way, it's the transformation from old mobility to the future of mobility. Vogel & Co. is one of the leading car dealers and mobility providers in the south of Austria. And as a consequence of the developments in the mobile world, Vogel & Co. developed new mobility services both for B2B, business to business, and B2C customers, business to consumers. In B2B, these are customized car sharing solutions using the IT framework by Ebiola and in cooperation with Steiermark. And in B2C, it's subscription models that are flexible alternatives to buying or leasing cars with full cost control. And for this, I'm glad that we are joined by the General Manager of Vogel & Co., Oliver Wieser, who came up on stage just a moment ago. He's a finance and restructuring specialist with 25 years experience in the leadership of financial management or general management. And after successful engagements in fashion, in sports, photography, he was appointed General Manager of Vogel & Co. in 2018. And his goal was to change the company. And this is his first job in the automotive sector, so I'm looking forward to hearing how you're doing it.
Thank you very much for the warm welcome. I try to give you in the next 15 minutes or 20 minutes, try to catch up a little bit of the time, a kind of a best practice example in our company and what we try to do in the circumstances of a changing world, especially in the mobility area, and to try to set up a new part of the business for the future. But first of all, I think it's important to look where we start from. And as you said before, and I don't mind, it was, I think, a very good description. We start from the point that the company Vogel & Co. is a very traditional company. It's more than 100 years old. The traditional model of doing business was like selling cars of 8 brands, of the French ones around Renault, and of the Italian ones around Alfa Romeo and Fiat. And also then repairing the cars, selling spare parts. So the traditional thing everybody knows who owns a car. And this in the region of Styria and in Burgenland. And when I joined the company 3 years ago, I found circumstances which are very much challenging, but also changing. So e-mobility gets more and more a factor for the future, but also new technologies we don't face so much in this moment, but will influence in the future our area. Let's think about connectivity, other green technologies, and so on. So the question was how to go on and to find projects to develop the company from a traditional car dealer to a mobility provider, which is our goal for the future, and to develop new product groups which we didn't sell before and which look more into, let's say, total concepts compared to what we did in the past. And for this, we developed a group of new services which all have the goal to be flexible and to give our customers a very good cost control. As Mr. Picard said in his speech in the very beginning of this morning, it's important to try and not to look to the problems which might stop or make things not possible and to look more to solutions. And that's what we tried in the beginning of this project, that we looked into solutions for the future of mobility, that we invested in market analysis and in looking how we can combine also the advantages of the service structure we have from the traditional part of the business and combine it with a future mobility service. And as I said before, in all the products, the idea was then to focus on some values, and main values are service, are being digital. So I will describe the examples later on. So nearly everything can be done 100% digital if the customer likes to do it. And even we know for the future we need to go in more digital and more, let's say, maybe easier ways for the customers to work with all the different products we offer. The new mobility products compared to traditional car sales, or the traditional way of owning cars, go in the direction that you know exactly what your cost will be over the period of time you are going to rent the product. It's, let's say, very easy. It's comparable to Netflix or different kind of subscription models which are known in the, let's say, new economy all over different branches. And they give flexibility, and they give also cost control. So maybe it's more easy to go into the detail and to explain the different products or the main products we offer in the moment. Starting with a subscription model, which works like this, that there are different kind of packages, starting with an urban package with small cars like a Fiat 500 or a Renault Zoe, 4x4 package, a package with buses, for example, or with family cars. So in the different groups, there are different models of cars. And for these groups, you have fixed prices, including, and that's the important point, everything. So it's included also the insurance, the service, the change of your tires or whatever you need. The only thing which needs to be done from the customer is to fill the car. And with the electric cars, even we have in the cooperation with Energie Steiermark, cards already provided with the car to fill or to load them on the public possibilities for free or with this card, which is already part of the pricing. Pricing is an important topic. It starts in the moment with $3.99, and then it depends on the size and let's say mainly the car class or type of car, and the price goes up to around €1,000 per month from the point of which is the rate. As I said, including everything for the consumer. We are very happy that in the first 4 months of this year, we doubled our contracts, our contract volume in this sector, and we see a fast growth and a change also in the mind of the customers. And that's even most important, that we now reach out to new customers which we haven't serviced before, or we couldn't service because they are looking for something completely different. They don't want to own a car. They don't want to go into leasing contracts for 3 or 4 years, and they want to have flexible solutions. Within this subscription solution, one of the big advantages is the duration. The duration begins in the moment with 6 months, and after the 6 months, it can be stopped every month. We in the moment already think about even going down to 3 or 1 month and making the change of the contract even easier for the future, and even shorter from the 6 months where we started with the product. For also the fairness, we try to make a pricing including 20,000 kilometers per year in the packages we offer. So in the comparison to the models in the market, I think that's very important that there are no hidden costs. Yeah, that's very clear. With this mileage, you have this price, yeah, and only if you go over, so the principle should be only if you go over, you have an extra cost. Beside that, we have a car sharing model which is also fully digital, working with an app to book the car, also to come to the place where you can get to the car, to open there even the door to the garage, to open the car itself. You only have the key inside the car for emergency topics. Everything else can be done digital on the app. You evaluate if the car is clean, if everything is fine, if there are no damages, or if there are one, you can put it digitally within the program and to transmit it. With this product, we have five places in the moment operating. We don't see so much scaling effects or scaling opportunities for the future as compared with the subscription model I described before. But we see it as very important to learn for us and to get a quicker response from the market. For example, which cars are working well, which maybe additional features are working well, and we can very quickly change on the products and on the, let's say, on the different cars or different setup of cars we are offering in this car sharing model. It's very easy, it's flexible, it's digital, as I described before shortly. So that's something we try to face everywhere. It's not a big difference in the different products. So these are the solutions for the consumers, the B2C solutions in our program. Beside that, we have also a very high focus on B2B. And for business customers, we don't speak only about companies, mainly, of course, about companies, about fleet management, but also we are working, for example, with communities or with institutions. The advantage for them is that we offer them a car with an IT program installed, with the possibility to track the car and also to customize the IT solution to the needs of the customer. This means if a community wants to run their own car sharing, they can build it up like this, that they say, okay, for the first 6 months, we want to give it for free. They can set it up in a way that you have an hourly possibility for their customers then to book the car, or that you only can book it on a half day or on a daily basis. They can have a low price for the starting period and then increase the price. All these customizations and the setup possibilities then are organized from the program. And we offer different service packages so that the customer can make a choice if he or she wants to have the full operation, so that we are also operating and customizing every changes they have or they need with the cars they are operating, or if they do it themselves and they only buy the, let's say, the setup, with a setup which also gives the tracking of the cars, also with interfaces to the bookkeeping systems for invoicing and things like this, or also to the home pages on CRM tools or whatever needed. Reference customers, for example, in Styria in the moment are the city of Kapfenberg, for example, or several smaller communities in the area around Graz. And of course, a lot of our fleet customers, or also new fleet customers, which try to reduce the amount of cars they are operating, because they are more flexible also in the handling of the cars. They even can make a difference if the usage of the car is for the company or public use or for private use. So you could make also a setup that private usage is built to employees if it's a customer fleet solution in a company. So you see that this is a very flexible system. Pricing starts with, for example, for a Renault Zoe electric car, for the full package, also with the IT system with 690 euro a month on a monthly rate. So I think these are quite interesting rates also for companies. And then it depends on the setup, what cars you take in. For communities, for example, often they are looking also for buses, for example, there are football or dance clubs or whatever. So they, in the moment, it's difficult for them because one administration person gets calls all the time for bookings, not in the last year, but not in normal times. And of course, this can be solved like a doodle check when everybody can come to a meeting. It's very easy, and it can be managed directly on the booking platform. So we see opportunities on both sides, on the consumer side and also on the B2B side for the future. And we think that the challenges are high and the demands are high to change to the new needs in the mobility service area in the future. But we also think that the chances are high, and even for us, the more important thing is to have this as a, on the one hand side, as a new business model, but the more important thing even is to have it as an important factor to change the company in a whole, in the thinking and in everything which is done on the digital world, also in the other areas of the company. And this is quite successful and makes us very motivated for the next steps and for developing new products in this area. Thank you.
Thank you, Oliver Wieser. That was really interesting to see that transformation going on. I wonder if you can give us an idea if maybe back in 1925, 100% of the business was selling cars. And of course, you were also a workshop, I suppose. What's that share today versus all other sorts of mobility? And where do you see it going?
And so the share still is, I would say, below 5% from the total business, but it depends also if you look to turnover, if you look to sales figures. But I think that the change will be very high, and there are studies in Germany that people are open for example, for the subscription models, which goes to an amount of 25 to 1/3 of all the cars which are in the market in the next 5 to 10 years. So I think in Germany, maybe they are one step further already than in Austria, but I think that market share for this kind of product can be 20 to 30% in the next 5 years.
Quite a lot. Just for clarification, is subscription the same as long-term rental, or is there a difference?
It's in fact the same. I think it's only the more with Abo is the name which is the fashion term and,
okay.
and the marketing.
Yes, I subscribe to that ideology. Thank you very much, Oliver Wieser.
Thank you.
And with that, we move to our last presentation, and it's time to shake things up. Although we've had quite a few shakers and movers, it's time to think disruptive. And my speaker is coming up soon. If we want to change the future of mobility, we really have to question our classic approaches and thought patterns. But disruptive thinking requires courage. Daniel Huber, who will be with us in this session, explains how unusual approaches have revolutionized processes over many centuries and have permanently changed our world. Daniel Huber is the managing partner and head of strategic design of Moodley Industrial Design GmbH. And together with his team, he designs and implements innovative concepts in industrial and corporate design for renowned customers for a wide variety of industries worldwide. Every innovative product development is preceded by a long look into the future. What are the requirements of the market, the needs of the target groups, the changes in society, the global challenges? I actually remember a few years ago, I saw from the design team of the initial Apple Mac that they were designing something that they called PED, which still had a telephone in front of it because they could not imagine communications to change, but they imagined computers to change. So we see how long-term the evolution of things is. So with this, I'll hand it over to Daniel Huber, and I'll also return the place in front of your Mac to you.
Thank you. So hello, everybody. Thank you for being here. It's a great honor for me that I can talk a little bit about our thoughts of the future of mobility. Before I start, I would like to introduce Moodley Industrial Design with a few sentences. We are strategists, we are design and innovation experts, and we feel responsible for the future. And our aim is to design to improve life. Moodley is a group, and so we offer holistic solutions. We have 4 units, service design, we have the brand identity unit, we have the interactive digital services unit, and industrial design unit. And the focus of Moodley Industrial Design is on designing, developing products, innovations. And on the other side, also one focus point is mobility. So we are about 120 people working for Moodley. We have 6 locations and 1 global team. So it's very international, and this is also very important for us to develop the future. We have to look what is influencing our society worldwide. We have experience more than 25 years with international leading companies and more than 700 projects worldwide. And I want to talk about intermodal innovation for reaching supermodal mobility. And I think from my point of view, we have to think a little bit more disruptively to change the world to better. And if we want to look into the future, we have to look into the past and how was the mode of being mobile? And thousands of years we were only by feet mobile, and this is still the most important way to be mobile. But there was an really disruptive idea and a disruptive invention at the beginning, and this was the invention of the wheel. And I think 99% of the mechanical mobility is based on wheels, and we have to ask ourselves what is the most effective and most sustainable way to be mobile. And it's the long distance train. But the choice of the transport mode is for more than 60% of the people is still the car. And we have to ask ourselves, why is it like this? And one of the reasons is that the advertising spendings of automotive industry is 10 times higher than from public transport. So we have to figure out the reasons why we are mobile. And most of the reasons are work, free time, and also shopping. And this causes a lot of challenges for the future because we have time is the new scarcity because we are losing time and time and time, and we are a lot of time mobile. And this we have also to look at our environment because the limiting factors are emissions and space. And the road traffic causes about 90% of the emissions of mobility. One mega trend is urbanization. Soon 70 to 80% of the world's population will live in cities. And what are the needs for future mobility? And the needs are, we need sustainable and holistic mobility systems. We need integrated chains for intermodal mobility. They are at the moment much more too complex. And we need a dramatically reduction of complexity, and this should result in the benefits for the users. We also should see, or should look that transport modes are seen as mobile living and working spaces. And I hate the word mass transport, and I think we have to change also here a little bit our thinking. Each of us is individual with different needs, and we have to meet these needs also in the way when we are mobile. Because we have to think about the services, we have to think about making mobility as comfortable as possible, because receiving a great customer service triggers the same cerebral reactions as feeling loved, and therefore we tell our clients, understand your customers and love them, and see your mobility offer as an excellent service. And when we designed in the last 25 years, last 20 years, a lot of mobility modes, we ask ourselves why intermodal mobility still does not work as it could work, because we have the technological background that it could work. And we figured out 3 reasons. And one of the most important reasons is because each mobility system optimizes itself. So the railway industry optimizes railways, trains, and tracks, and did not change since 150 years the system. But there was also a disruptive idea at the beginning, and this was the iron tracks laying on a cross-country road, and this made transportation of passengers and goods much more effective. And if you look at automotive industry, you see that about 120 years of innovation there are a lot of detailed technical innovations, but the system did not change. The architecture of the base concept of cars is still the same. We have 4 wheels, we have 1 car body, we have 5 or 4 seats, and we have a steering wheel and the engine in front. And if you look at the benchmark of the branch, you see 40 years of innovation. There are a lot of innovations inside, but the system innovation I miss completely, because it's, even if you have this Golf 1 or Golf 8 or Golf 9, you're sticking in a traffic jam in the same way. But there was also a disruptive idea at the beginning of car industry, of automotive industry, because the idea is very genius to change horses into horsepowers and to put these horsepowers into the vehicle instead of front of the vehicle. And the reason too why intermodal mobility does not work is because we do not think in holistic systems. We did in the past a lot of things like trains, like cars, like bicycles and so on. And our clients always told us, okay, our way being mobile is the ideal one. But we figured out that this can only be a combination of transportation modes that brings us into the future. And the reason 3 why intermodal mobility does not work as it could work, because we do not have compatible systems, and here we focus on the hardware systems. And our answer is system innovation that we develop with the support of Siemens Mobility, and we call it One for All. And in the center of this mobility system or system innovation, and we call it therefore supermodal mobility. We want to build it up out of intermodal innovation, and in the center is a kind of pot, and this pot has an structure. This is normed by the dimension, and you can fill and customize the interior of these pots with whatever you want for passenger transportation mode, different transportation modes, and also for transporting goods. And here you see the raster. We have a special raster of the dimension, and this system fits to a railway carrier system, to road carrier system, even to Hyperloop, to metro, to ship systems, and also to air and drones. So we have a multi-directional super-modal mobility. And as pictures say more than 1,000 words, I show you a film to explain a little bit about the system. I think we need the sound also.
In the streets, are you floating with me? Trees on the meadow, are you reaching out for me? A new beginning, an early
Yeah, this is our vision of the future of a sustainable mobility, because it's completely autonomous. We have sustainable energy system within, and yes, we will see how and when we can realize it in the next years. The second project I want to show you is the DTM Electric. It's a Deutsche Tourenmasters. It's a very famous race series. And also, as I told you, automotive industries spend a lot of money in advertising, and race platforms are also marketing. And we have also to think about going green and make it sustainable. Car racing is not sustainable at itself, but it's a perfect platform to make sustainable mobility popular in the broad population. And therefore, together with Scheffler, who did the whole innovative technique for this demonstration car, we did the car styling, the design of the car body, and also here I will show you a short film.
Engine running. 4, 3, 2, 1, 0.
this race platform is also a perfect platform for developing innovations and to bring it into series. The next study, it's a concept I want to show you, is the Volta Stradale Long Rider. It's a concept for a street racing bike with full suspension and with electric support and power. And this is also an idea of a shift of paradigm because it's not only a sport tool, it's a new way of being mobile because it's also thought for people who are not super sportsmen, but they want to make distances of about 300 or 350 kilometers a day. So this is a travel mode from our point of view. And last but not least, a very innovative project that we did for our client Rosenbauer. Rosenbauer is an Austrian company. It's world market leader in producing and developing firefighting equipment and firefighting vehicles. And we started in 2003 to develop, this was our first project for Rosenbauer with the Rosenbauer Panther. And Rosenbauer Panther is airport firefighting vehicle, and in this time we developed a benchmark for a design benchmark, and then we designed all vehicles and nearly all products for Rosenbauer. And in 2015 we made the second generation of the airport firefighting vehicle, and one year later we started with this concept fire truck. And the concept fire truck is in this branch the first fire truck which is powered by electric power. And the interesting thing is this was a concept, and the concept was promoted in 2016. And the feedback was so excellent that Rosenbauer decided to bring this concept into series. And so we developed the RT, it's called revolutionary technology. And the interesting thing of this project is that this new way of the energy with a range extender allowed us and the team of Rosenbauer a completely new architecture of the vehicle. And it's very important because also the megatrends of urbanization, people get older, more women go where firefighting become firefighting women, and so also the interior allowed a new way of ergonomics and a new way of communication within the firefighting team. Yeah, thank you very much. I think one of the first firefight brigades was Amsterdam, the Brandwehr, and it became a big success for Rosenbauer. Thank you very much.
Thank you, Daniel. Very interesting. And of course, while boys like toys like fire trucks and racing cars, I was most impressed by the pod concept. But then again, it's a complete rethink. Do you think something is possible to, and where would you start?
Yeah, for sure. What we do not want is that we make concepts that are hidden. Then we want to make concepts that are realized. And from my point of view, it's a very holistic system and a system innovation, and it cannot be realized from today to tomorrow. But what we plan and what is realistic is that we figure out some derivate projects, pilot projects, and realize it step by step. It should show a vision how mobility could be in the future.
I think it brought me back to the subscription idea from Vogel & Co. because in a way, personal ownership of your transport mode makes you stuck with that system. And so if you turn towards mobility as a subscription, you're also more willing to change the mode of mobility.
Yeah, from my point of view, the most difficult thing is to rethink systems because as the One for All film showed, we want to use existing infrastructure because it's very expensive to throw away roads, rail tracks and so on. So we use it. And this is also a kind of innovative thinking in using existing things, you know.
Now,
cannot change everything.
railroads and cars had 150 to 170 years of developing their systems. How long do you think developing a new system would take?
Maybe when we are all a little bit more disruptive, we can realize it within the next maybe 20 years.
All right, maybe there's another pandemic that disrupts us and forces us into new ways of thinking as this conference is. Thank you, Daniel.
You're welcome.
Thank you at home, in the office, wherever you have been following our afternoon session. We have seen a way of changing conferences into something new, hopefully at some point not just out of necessity, but also out of finding the best of many worlds. As in this point. So with this, I would like to remind you, if you have any questions to follow up, please send them to Mitterer, M-I-T-T-E-R-E-R, @acsteria.com, mitterer@acsteria.com, and he will pass them on to the speakers of this session. With this, I would like to thank all the speakers for their engagement this afternoon. I would like to thank you for following us in our stream. And thanks a lot to Acsteria for putting this session together. That was Gerhard Mitterer. Thanks for the technical support staff and for everybody who made this possible, and have a good evening. Thank you and see you again.